online, for those who are online. So today's seminar is focused on the evidence in focus using visual analytics to shape the future of insecticide-treated nets procurement. So here it's about re-examining the important, like one of the most important tools that we have for malaria through the lens of cost effectiveness, technology, and also field evidence. Can you hear over it? Yeah. Welcome.
There's more coming right now.
More coming?
Yeah, more now.
So malaria still affects a lot of children in Africa. So one of the most important tools that we have still in use is vector control interventions and insecticide-treated nets. But we have to ask ourselves a few important questions. Are we investing wisely? How can innovation support better monitoring? And how can what can we learn from the tests that we're doing on a regular basis? So today's the three speakers that we have will address these three questions, and they will try to answer to some of this from a different but very complementary angle. So after the talks, we'll open the floor for Q&A. So please take notes and make sure that we have questions for them after. And then also let's continue the discussion after we're done through an apéro. So to start, I would like to introduce Professor Sarah Moore, who is the first speaker of today. She's a leading researcher in malaria and dengue vector control. She has a joint appointment at IHI and Swiss CPH, and she'll guide us today through how economics perspective can drive innovations and can better inform the choice in malaria control. So Sarah, the floor is yours. Thank you.
Thank you very much for the nice introduction, Emily, and for being our MC today. Much appreciated. So I have the pleasure to be one of the key eyes of the ViALLIN project, which is funded through the BRCCH in Basel. And the aim of our project is actually to save more children's lives through making more cost-effective innovations available. So we have the humble bednet, a beautiful technology, and about 3 billion of them have been distributed since the year 2000. This has resulted in about 1.5 billion malaria cases averted through this simple technology. And we have done really great things. So when I first started as a researcher in the year 2000, two children every minute were dying from malaria. And now here we are in 2025, and it's one child every minute dying from malaria. So if you take some pause to think about that, that's 4 jumbo jets full of children falling out of the sky every day. It's an incredible amount of mortality that needs to be averted. And the bednet is one of the best technologies that we have to do this. And so our project is to optimize this life-saving intervention. Bednets are super effective. I'm going to talk a little bit about mosquitoes. It's my job to be obsessed about mosquitoes. I think like mosquitoes. I think about what they're doing constantly. Myself and my husband will have a bottle of wine on a Friday and talk about what mosquitoes are doing. And the way that they work is so important for how we design technologies. So this is an African village, and there are 3 species of mosquitoes that are really good at spreading malaria that live in sub-Saharan Africa. And they co-evolved with humans around 10,000 years ago when we started clearing forests and making spaces for agriculture. And so they have a reliable blood source. Humans are inside late at night, asleep, so they're not very dangerous. They fly towards the very reliable odors of human feet that say that that's their host. And then they feed at the safe end, away from where they're going to get swatted. Then they rest on the walls inside people's homes, which are nice and cool and dark and safe. And then they breed in the disturbed environments around the village that are created by humans, where there is a regular supply of water that we use for agriculture. So much like rats and cockroaches, these mosquitoes have co-evolved with humans to be very dependent upon us. So if you put a barrier between the sleeping person and the mosquito looking for that human, and then add an insecticide on it, it's a beautiful intervention. It's a lure and kill. very, very effective and reliable. And this is work I borrowed from your group, Emily, showing that basically in Tanzania, as bed nets went up, malaria went down. Beautiful. So we've done all we need to do, right? Well, unfortunately not. And this is where the ViALLIN project comes in. Because around 2015, coverage of ITN, a long-lasting insecticide-treated nets, stalled. We got to a sort of fixed number of nets, and at the same time, the gains we'd been having in malaria control also stalled. The two things are highly related. And the reason that this is happening is very much financial. And also in sub-Saharan Africa right now, there is a population explosion. And by 2050, there will be 2 billion Africans. Right now, there are 1 billion. And so we have to be thinking smarter so we can spend our money more effectively to cover this larger population. And also we have additional problems, climate change, instability, political instability. And now we have the great financial slashing of President Trump and the issues with NATO that have led Europe to also reduce the funding available for overseas aid. So how can we improve our beautiful intervention so it works even better? So this is how ITNs work. Mosquitoes come in where someone's reliably asleep. They might get annoyed by the bed net because it has an insecticide on it and fly away, and they're alive and they go on to bite somebody else. They could contact the insecticide and die. This is good. The only good mosquito is a dead mosquito when you're in my trade. Or they could get in through a hole in the net, feed and then die, or they could feed and survive. So as we use our bed nets, we wash them and they might get snagged on a nail or children might pull them. They get more and more, less and less insecticide and more holes. And so what matters the most? When we're going to make a better bed net, what should we be doing? Better insecticide or stronger material? So we do work like this at IHI, where we test these hypotheses. So we've got a bunch of bed nets with different levels of insecticide, different levels of damage. Our brave volunteers release hundreds of mosquitoes from cups and go to sleep. And then in the morning, recapture them and they figure out what state are those mosquitoes in. Are they live unfed, alive and fed, dead and fed, or alive and fed? So the 4 categories. And you can figure out what's going to happen. So if you have no net, you have this bad situation where the mosquitoes are alive and fed and they go on to do their thing. And so they have more offspring and then they can continue to spread malaria. But it doesn't take, and as the net is getting damaged, if you get a good insecticide on that net, it doesn't matter if the net is damaged because the malaria is still being controlled because the mosquitoes are still not feeding. And even better, they're dying. So that even people within the community that don't have access to a bed net have less probability of encountering a mosquito and getting sick. So it showed very clearly that the chemistry matters the most to the mosquitoes. Even a damaged net, still working. Never throw away a bed net. And now we have wonderful work done in both East and West Africa showing that new chemistries which work against pyrethroid-resistant mosquitoes halve the amount of malaria you can expect to have in a community using those nets. So we have amazing chemistries right now. So problem solved, right? But unfortunately, they only last for 2 years. And so that leads us into the situation we have now in sub-Saharan Africa, where we have only about half the population that needs to be sleeping underneath a bed net are sleeping under a bed net because the nets are lasting for 2 years and then they're being thrown away. And this is leading to the sort of loss of cascade of effectiveness. This is work by Clara Champagne, showing that you have this big drop because people are throwing nets away. And the most high predictor of a net being thrown away is how much damage it has. This is also work from Olivier Briet, showing that the best thing for reducing malaria is using a net, shockingly, and having a good insecticide on the net. But the more that you use the net, the more damage it gets, the more likely it is to get thrown away. So some recent work that Emmanuel has led actually with one of his students has shown that this net with all of this damage is 4 times more likely to not be there next year than a net that hasn't got much damage, because the user is the person who decides the end of life of the net. It's not the mosquito. That net will still be killing mosquitoes, but sadly it will be thrown away because the mosquitoes are getting in, they're bothering the user, and they're creating a nuisance. So it's better to sleep without a net than have one underneath there buzzing around your head and disturbing your sleep. But unfortunately, LM market price is driven by not the consumer, the end user, or the National Malaria Control Program, but by donors. And donors just assume that all nets are exactly the same. They're all going to do, as long as they have the same chemistry, they're all going to be exactly the same. And so as long as that net is super cheap, that's fine. Doesn't matter if it's made of a very fine material or a very strong material, they're all treated the same. And now we have these amazing new chemistries, and so the prices of nets have increased. And so now we have a growing population and increasing costs for nets. But unfortunately, this is what it has led to. This is a net that was found in the field, is 1 year old. And this is apparently a standard net, which is costing $3. So what we need to do is incentivize quality, longevity over rock bottom price. So we have to change the way that nets are procured. And this is not easy. So we started a few years back looking at whether or not all nets were the same. Are they all created equal? And what we did see is that there is a substantial difference in how long those nets last. In this case, where nets were in houses in the same village, some nets lasted 20% longer than others. And when you turn that into an equivalent annual cost and you figure out how many nets you need to cover a country the size of Tanzania, you can save hundreds of millions of US dollars by switching from a net that is the cheapest to one that's slightly more expensive, but is going to last that little bit longer. And now some really nice mathematical modeling, again, coming out of of Emily's group, along with Chai, has been looking at how much malaria we can avert by getting more cost-effective, more durable nets. And about 11% more malaria cases could be averted if we get nets to last 8 months longer. So that's a 30% increase, more or less. So we have to persuade the procurers to buy the longer lasting nets. The only way we can do that is with data, but it's very expensive to gather this data. We could insist on having very strong nets, and if you make nets more resistant to damage, there is about a 40% probability we can predict how long that net will last. But 60% of how long nets last are actually because of the environment that you're using the net in. Is it an improved house or an unimproved house? And how people care about their nets. Do they value their nets? Do they repair their nets? Do they wash their nets carefully? And so you actually have to be collecting data at a country level in order to be able to pick the best products for your setting. So this is where ViALLIN comes in, because we need to make this sub $100,000 for countries to be able to do this and make this data used by procurers so they actually can be selecting nets based on their quality. So what we're doing right now is we're taking all of this household information, the 60% that matters. We're looking at different products. So we have 3 different products Emmanuel will talk about in a moment. Then we're taking the image of the net damage, which is the big thing predicting if that net will be there the following year, which Philippe will talk about. And this will go into AI. So we want this to be able to go into malaria control program dashboards where that can be used by policymakers so they can actually decide when to plan a long-lasting net distribution and also to monitor the quality of the nets that they are procuring. Because we need to create a virtuous circle where programs are deciding, I want that product because that product is going to last 20% longer than that product. And then they can take this evidence to procurers. When you have volume guarantees in procurement, that then incentivize the manufacturers to produce nets that are greater quality. I've spoken to numerous manufacturers and they all say, yes, I can make a stronger net. Yes, I can put a better chemistry on my net, but there is no reason, no financial incentive at all for me to do it. So this is the whole point of ViALLIN. So we can get this data out there, get it used, and then hopefully that will incentivize this better quality ITNs. So this is an overview of what our project is doing. And we're going to go beyond just standard net and design the ultra net. And then I will hand over to Emmanuel, who's going to talk to you about that. Thanks.
Thank you, Sarah. If you have any burning question for Sarah. If not, we can also have them at the Q&A session. No. So I would like to introduce our second speaker is Emmanuel Mbuba. He is a public health scientist at IHI and is leading research on insecticide-treated net innovative malaria control interventions in real-world conditions. So today he will talk a little bit about the field settings and the field perspective and sharing like how the emerging evidence of durability like can fit into the ViALLIN project. So over to you, Emmanuel.
Thank you very much. So I would like just to start with public integrity of the items. As Sarah mentioned, that the damaged net is 4 times more likely to be discarded compared to the new net or good net. That, I mean, if you think, probably this is the most critical aspect of the net that we should be focusing at. So in this project, the ViALLIN project, this thing, I mean, this concept, you have tried to work on it and try to come up with new items that can actually help extend the lifespan of items. So what we have done, I just talked through, oh, the technology is a problem.
No. This is, yeah.
So this is the point I was trying to make. So you can imagine this net were found in the community in Tanzania, and you can see who can use this net. Maybe after distributing the net, can you predict or can you estimate how long this net is going to last? One of these net is just 3 months old in the household, and people are still using them. The mass campaign comes after every 3 to 4 years, up to 5 years. The time between mass campaign, very likely people are not protected. That's why Salah, when he was talking about the using the long-lasting net, which can have more lifespan, is very essential and can help us at least mitigate the challenge that we're facing. Now, because of these challenges, the WHO requires that for every item that is pre-qualified, it's supposed to be evaluated under community setting to determine first its lifespan. Number 2, to confirm whether it has, to identify the best performing items. And number 3, whether these items can be procured by policymakers. And then, because of this, in the ViALLIN project, we came up with idea on how best we can make a net that the community is actually willing to use. So to do that, what we did, we tried to engage the community itself to give the feedback, what net do they want manufacturer to make. So this is the point I'm trying to make here. On the left hand side on the top, you will see that we sat with the community, made some interview, presenting with them different net with different physical condition, colors, and so many aspects. And then the community members were able to tell us what kind of net they would like to use when it is available. So next, we went to the manufacturer, as Sarah mentioned, we went to one of the manufacturers, discuss about the preference of the community members, what kind of net they would like to use. And after that, the prototype of that net was made. And what you see here, the net was ready to go to the community. So I'll be talking more about the field implementation of the trial that is evaluating these items, new items. It is called Clonet Duo, but it is being implemented in the community alongside the standard of care net in Tanzania, which is Orseti Plus and Interceptor G2. What is so different with this net? It has a different design according to the end user's preference. The net itself, it has been knitted in such a way that at the bottom, even a strong man in this room, you are not able to, once it is cut just a small, let's say 1 centimeter hole, if you want to extend it to a bigger hole, I'm sure when I say even a strong man in this room cannot do that, because I've done this with the community in Tanzania who are believed to be very strong, the so-called Wasukuma. And why that part at the bottom, most of the holes are happening at the bottom part of the net. So in that particular part, it has been knitted to the extent that even if this net, it is held on the nail on sharp corner of the bed, still cannot tear out. So that is the one thing which is very much improvement on this net. And number two, it has bigger hole on the top, which allows airflow. And number third, when someone is sleeping under that net at the center, don't know how to say it, but at the center, it has a surface which is slightly not scratching. So this makes that the end user, when he's sleeping under that bed net, accidentally touch the surface, she or he will not feel that he's being scratched by something else. At least it gives him or her some interesting pressure. Therefore, I have talked about the physical characteristic. In terms of chemistry, as Sarah mentioned, this net, I think this is the first net with the bifenthrin. This is a new chemistry, or this new compound, this for the first time being used on the items. And when tested in the experimental heart studies in Tanzania, Cote d'Ivoire, and Burkina Faso, it has been shown that this net is actually killing more mosquitoes compared to one of the best performing nets in malaria endemic countries. So you can see it's actually working more better than Interceptor G2, if you see in terms of this graph. So now we have done two things. One, we have worked out on the physical characteristic, making it more stronger. Number two, it actually has proven that it is killing more mosquito compared to the standard of care nets. What next now? Let us take it to the community so that we can evaluate it under end user setting, given that the net was made after listening to the end user. So in the community, we are doing this trial in order to understand several parameters according to WHO criteria. And one of them is survivorship, bioefficacy, fabric integrity, user acceptability, as well as something that my colleague will talk about, image analysis. We're collecting images of this net found in the household so that you can try to go further apart from the standard of durability monitoring of the items, whether we can improve this by using image analysis. So, as I mentioned, this is the new method to estimate items damage in the community. And the study itself will be for 3 years. But, okay. So imagine how many times do we use this community durability data for the items into decision-making such as procurement of the items. People, I mean, the story about net are not lasting longer in the community is always there. But at what time do we use this information to inform procurement? That is a big challenge. And through this project, what we want to do is actually to ensure that we are able to change the policy for procurement of items in Tanzania. And for us to reach to that end, we must make sure that everyone is involved. As we have involved from the beginning, the community, they said what they want, involve the manufacturer, said, I mean, has responded to what the community is in need. Then for us researchers, we are playing our part. What about the policymakers? So this was the first engagement, engagement meeting with stakeholders in Tanzania. And we have engaged more or less like everyone who is working on the items in the country, including people from the Ministry of Health. And we have another ministry in Tanzania which is working to the, at community level, and we have other team members. So we sat together, shared all this information, and discussed about how best we can do this trial. And our end point, we want this trial to inform the policy decision in Tanzania. So that's why we wanted to ensure that all the, every member is involved from the start of the trial to the end. So this was the first meeting where we came up with the trial design, site selection. And for the site selection, you can see that the trial at the moment is being implemented in Geita region and Shinyanga. These are the two regions with the highest malaria burden in the country, according to 2023 data. And these data were coming from school children. Prevalence of malaria, for example, in Bukombe was nearly 50%. Bukombe 47, then Mbogwe, again 45. All these sites had so much malaria among school children. And this site now were recommended by the policymakers that if you want to save people with this net, which we are actually claiming that is better, probably more than the standard of care, please take it to those who actually need it the most. So we started this trial, as I said, we are having 3 nets, ProNet Duo, Interceptor G2, and Olicet Plus. I'll not talk about more about this information, but at least I've mentioned that ProNet Duo and Interceptor G2, these are having more or less comparable insecticide, with both having chlorphenapine and one chlorphenapine and the other one chlorphenapine and alpha sapamethrin. But interesting is that, as you saw in the previous slide, even though they're having the same kind of insecticide, still, ProNet Duo was able to kill more mosquitoes in the experimental heart compared to the Interceptor G2. Other parameters are so much standardized, and we ensured this is that way so that we don't introduce bias in the trial, because some may be preferred one of the net against the other because of size, color, or shape. And the trial itself is a longitudinal household randomized trial happening in 4 different districts in Tanzania and 8 villages. Again, I'm coming back to the same story. We have done our best to ensure that everyone play his part by engaging all members from the national level up to the village to ensure no one is left behind. And all this effort is actually to make sure that by the end of the project, you are able, all the members, including the policymaker, they're able to take up whatever is coming out of this project, as long as it is good for the community. We did not end up there just by involving the community. So we again went to the people at the village level, we had so many ways to engage them, to sensitize them. And we did not have just a uniform way of sensitization approach. In some of the villages, we ended up having a football match. Some of them we ended up general community meeting. All this was just to make sure that the community is aware of the study and also is aware of what is being happening, in their areas. And we are very lucky that participation of the community was quite high in this trial. Then the trial began. As usual, this is the study, it's not program implementation. So whoever is participating in the community has to be consented and agree by signing a written informed consent. And after that, households were numbered and baseline questionnaire was conducted. After baseline questionnaire, we're able to distribute the net the same day. Actually saved quite a lot of money in terms of we don't have 2 times to visit the same household. Just you go direct there, talk to them, recruit them, give them the questionnaire, identify the sleeping spaces. So at the end, every household was covered by items required as per sleeping spaces that were available in the household. So we were able to distribute this bed net. I have tried to not list the brand name, but this is the way we have done so far. We have reached up to 600 and nearly 50 households for each brand of the net that we distributed in the community. This sample size is quite high. And in terms of community preference, the community was very, all the net were very accepted by the community, up to almost 97% for all the brand. But this was based on information. Some of the pictures I have shown you, they just came out of one of these study nets that we just distributed. We'll know the story once we go back to the community. The full story, we have it, I think, this December, January. Probably this story about community acceptance and everything will change after 12 months. The next step that is ahead of us is we are going back to the community to collect household information. Also be, for those net which will be still in the household, we need to to assess them for their physical integrity by counting number of holes, the most tedious job. And number 2, taking pictures for image analysis. Okay, I need also to talk about this a little bit. We are trying to implement this study very strategic. So we have a master's student who is assessing what are the bottlenecks and enablers in Tanzania that can help us in the process of uptake of these study findings. This student is coming from the Ministry of Health, National Malaria Control Program, and he is supported by the project, and thanks to BRCCH for this. So the end point we want is actually to make sure that by the end of the project, things are not just going to be project research as usual. We want to have impact. And this is the way we anticipate. Our vision is actually to have impact. And to have impact, we need to generate this evidence data, have stakeholder engagement effectively. Then we want to make this translated into policy in Tanzania. And most of these activities are still ongoing. And we expect by next year, we'll have much more solid information to start dialogue with the Ministry of Health and all members in the country. Overall, I need to thank BRCCH for this support. Also the participants for accepting to participate in this project, without forgetting stakeholders who are the minister, district councils for all these district councils, as well as collaborators, Ifakara Health Institute, Unibus, Swiss TPH, and Minister of Health in Tanzania. This is the end of my presentation.
Thank you. Thank you, Emmanuel. Thank you for grounding us in the realities of usage, net usage, and durability. Do we have any questions for Emmanuel now? Yes?
Just one question. Why don't you have a control arm, i.e. the current generation of normal nets as controls? Because if you want to make an argument about better cost effectiveness, that would probably be quite useful.
So I did not get you.
Why don't we have a pyrethroid down?
Now in Tanzania, we don't use pyrethroid only. It's all SETI plus or interceptor G2 only. So we don't have pyrethroid only, pyrethroid net in Tanzania simply because of resistance levels. So we don't have.
But then you somehow have to maybe account for that when you do the calculation.
Okay. The good thing is, as I said at the beginning, we sat together with the Minister of Health, and as long as they say they are not risking anyone in Tanzania to continue using pyrethroid only net, while we have the best performing net, which was all SETI plus. Now they are taking all SETI plus together with interceptor G2, which have shown that they're more better than pyrethroid only net. And I think convincing them going back to use pyrethroid only net, I don't know which kind of energy you need to use, but it's difficult.
Thank you, Emmanuel. Thank you again for this. We'll have more questions at the end of the session. So our third and last speaker for today is Philippe Catin. He's a professor at the University of Basel, and he is the founder of the Center of Medical Image Analysis and Navigation at the faculty of the medical faculty. So welcome. Philippe works at the cutting edge of artificial intelligence and image analysis, and he will take us today to show us in this use digital photos and analyze them automatically. So the floor is yours.
Thanks a lot. I would like to thank my previous speakers for the nice introduction into the problem. And as you can see, Emmanuel and his team distributed quite a lot of these nets. And of course, in the future, they would also like to roll this out, possibly to other countries. And for this, we would need some automatic AI support in order to help analyze these bad nets. And basically, as you can see, when you distribute the nets, of course, and this is what just happened, the nets are in good shape, but the question is then in the next year, what happens? We have to get these nets back, or basically go to the villages, take images of these bed nets, such that we can assess what is the state of these nets then at year 2. And potentially in the future, we would also like to predict on how a bed net then develops in the future, because we have to make assessments on when to change these nets. And of course, with the same methods, we can also evaluate which of these bed nets are possibly the best ones. There is a WHO method for assessing the hole in these bed nets, and it's a quite simple approach. It's basically the hole the size of a pinky, a thumb, a fist, and a head. So these are the 4 different sizes that are distinguished, as you can see in this table here. And this is the whole size in centimeter that they estimate the range of these hole sizes. And as you can see, then the head is everything that is bigger than 25 centimeters. And they give each of these corresponding sizes an additional weight here. So if you have a hole of the size of a pinky, then you basically count how many of these you have. So it's basically, let's say it's 5, and then you multiply it with the weight. So it's still 5 times 1. So this is then what you give for for the pinky sized holes, and here are the number of size 2, so the thumb sized holes, you multiply them by 23. And this way, you basically come up with this whole size index, this PHI that the WHO has defined. And they also came up with some thresholds that basically should help you to decide whether a bed net has to be changed or whether it's still serviceable. As you can see, these are very rough and coarse estimates, and probably not ideal for the evaluations that we have in mind with our assessment. So this was the idea behind the ViALLIN project, that we develop image analysis techniques that basically can do hopefully a better job at assessing these bed nets. And this is what we did. Here you can see one of our first images that we took in the field, which was made by Emmanuel and his team. And as you can see, there's already a couple of challenges, and I've listed you some of these challenges. If you have if you want to develop an AI algorithm to do that, we already made the first change that I did not even list there. But probably if you remember the images that Emmanuel has shown, in this, we already have a back cloth as a background. So initially they started with a frame, that just a metal frame where they put the bed nets over. And this, of course, is very difficult for the AI algorithm then to see the holes, because you can also see the backside of the net, which would have made it very difficult to segment these holes. This is why we came up with the idea to use a black cloth and then put this black cloth over the frame and then the bed net on top of it. So this was the first quite obvious change that we asked Emmanuel to implement, but there were many of the difficulties that we actually did not recognize in the first place. And this is the very variable background that we have. When you have these bed nets, they put them up somewhere in the villages outside. We don't really know what we can expect from the background. It might be, we even have images where there's the sunset. These are very nice images, but for image analysis, it's very difficult if you have a sunset in the background, because this puts on challenges. We have very bright scenes here, where basically the image is even overexposed. So this is very bright scene. And these variable backgrounds, of course, we have to take them into account. Our method has to be robust enough to tackle these. There's also perspective distortions. And I deliberately took this image. We will then see it later on. Perspective distortion is when I look at my cell phone head on, I see a nice square. But when I look at my cell phone and it's slightly slanted, then this is what I actually see is not a square anymore, because this side here, because it's further away, it appears smaller than this side here. And this is the perspective distortion. And when we want to measure the hole sizes, we have to take this into account. And you can see this because we will see it in a later slide, but when you look at this edge here and an imaginary edge here, you can see that these lines are not parallel anymore. And as long as these lines are not parallel, we would estimate the holes on this side here smaller than the hole of the same size here on this side. So these are the perspective distortions we have to take care of. Then I also mentioned the bright background. Another challenge is the uncalibrated cameras. For this project, we bought some tablets from, I think, from Samsung, but it doesn't really matter. But we did not want the people to having to calibrate these cameras. This is what we do in the medical field. Normally, when we buy a camera, we want to use it interoperatively. We show a chessboard, and then the user has to capture dozens of images from this chessboard at various different distances. And from this, we can correct lens distortions and whatnot, and make then really accurate measurements. And in order to apply this in the field, this is not suitable. So our methods have to be robust enough such that we can work with uncalibrated cameras where we don't know exactly the properties of all the lenses. And then, of course, there's also different lighting. In this sense, I meant that they could be, or we definitely have type of images where half of the bed net is illuminated still with the sun, half of it is in the shadow. And so we also have to deal with these type of challenges. So the ones that I highlighted right now, they're in a way quite easy to solve. Easy in the sense that we just have to ask Emmanuel to capture lots of bed nets under various different scenarios. So we want him to capture bed nets where the bed net is half of it is in the sun, half of it is in the shadow. We want him to capture images where there's people, cars in the background, because then our AI algorithms, they learn to ignore that how the background could look like. The same applies for bright background, so with and the different lighting conditions. So the more images we have with diverse backgrounds and properties, the better our algorithm learns to deal with these type of situations. But there's still challenging aspects like perspective distortions and uncalibrated cameras. For perspective distortions, I'm quite happy to realize, and I actually included it in my lecture now, because I'm teaching computer vision at the ETH and here at University of Basel, I think since 2006 or so, since over 20 years, and I've always taught multi-view geometry, and I never had a really nice application for the theories that I teach, and this was a perfect spot-on application. Because in order to correct for these perspective distortions, one solution is actually that we look for these edges here. And as you can see, these two lines here. Yeah, I have to point them out here in the computer. So this line here, they're converging. They're not parallel anymore. So what we have to do, we have to find these lines here. And if we can calculate the location, the coordinate of where these lines are intersecting, then we are halfway through, and we also have to extract these two lines here. And as you can see, also these lines are not parallel, so we have to find the intersecting point. And if we can find the intersecting point, we can calculate the line at infinity. Don't worry if you don't know what the line at infinity is, but this is then three numbers. This line at infinity, and we can put it here. This line at infinity, and we can actually then undo this perspective distortion. So this is a quite handy application that now all my students, since about 2 years, all my students have to do this exercise on one of Emmanuel's bed nets as an exercise during the lecture. So we can deal with this, with these perspective distortions, because only when we can correct for these, this is what you can see here on this side, we can actually calculate the areas correctly. When we correct these perspective distortions, the main thing is that the lines that are in parallel, they are still parallel. And if they are not, if we don't achieve this, basically, we make errors in our size estimations. Uncalibrated cameras. What we want to have from these holes, so we want to measure them, or we want to be able to give like a square centimeters area that the size of this hole is, but we don't have, with uncalibrated cameras, we don't really have a ruler. We don't know at what distance the objects are, so we cannot properly tell this, but our solution was that we basically have to know what the frame size is. So all our measurements, they depend on the frame size. So we have to recognize the corners of the frames. And as long as we can do that, and we know what the size of this frame is, we can then basically make absolute measurements for all these holes that we have here. So this is another problem that we solved. Then we thought, okay, we are fine. We solved all the problems, and then we basically put an A4 sheet, or I think it was an A5 sheet then, in the end, on these images, because we wanted to see whether we really get the size of this A5 sheet correctly with our measurements. So this was our measurement standard that we put there, and we realized that there's actually still some unaccounted for errors. And then it took us some time to realize, but when you look at this edge here, this is bent inwards, and this is wind. And we did not take this into account, that we should also look for wind distortions, because this wind pushes at least the black cloth, sometimes also the bed net inwards. And so we also thought that we have to correct for these wind distortions. We tried to do this. So the first thing we did is we changed this grid. As you can see in the image before, we had just horizontal lines. So we also made vertical lines on this cloth, such that once we have estimated the holes or segmented the holes, we can also segment all the corners here. Once we have the corners, we can also get an idea on where the image is slightly distorted or where we have to correct for these inaccuracies with wind. Okay, I think now that we have this nice pipeline, we developed an application. Was developed by my student Natalia, because Emmanuel and his team, they took a lot of these pictures, as you can see, and then first we needed some ground truth. And this ground truth was that they manually segmented. So this is what is marked here in red. They manually segmented all these holes here. They manually segmented the frames here, because we needed to use them as our ground truth to train our AI algorithms. And what we did in addition, we printed out QR codes of different sizes. So these QR codes, we made 3 different sizes depending on the hole. You take a different QR code, and then they take images of these QR codes. In this QR code, is basically encoded what is the size of this QR code. And then once we know the size of this edge, we can very accurately calculate also what this image is, what basically this hole is, because here in this image where we have the full view, we have inaccuracies because the holes might be very small. So we took, in addition to each of the holes, we took a ground truth image with this QR code next to it, which is basically like a ruler. When you normally want to assess how big is something, you see the image, and then next to it there's a coin, such that we have some reference. And these QR codes are basically our reference that allow us to even better assess what is the accurate size here of this hole. And as we can see in this table here, they nicely correspond. So if we have the ground truth from the high resolution one to the area here that they manually labeled, this nicely corresponds, and we can have yeah, this is exactly what we want to know. So with this, we can now develop our workflow. So basically, Emmanuel takes 5 different pictures of this bed net from all the 4 sides and the top. And then our network basically then, or we have, depending, we tried several different networks. So we have different versions, but we can basically then segment the holes that we see. And it's not only the holes, it's also the bed net below here, because it might be torn. So we segment the hole here and the end of the bed net here. But we also have to segment the frame, because as I have explained to you, we need to know the size of the frame in order to get a ruler. So this is our coin in the image, where we can then make absolute measurements. And we can combine this into a measure where we can accurately calculate the size of the holes in square centimeters. So this is what we did here, and you can see here. So these are the original images here. Here we can see with the hole segmented, so from the different sides. And here you can see this is the frame that we segmented. And then basically we can calculate what the area is. Here you can see a comparison. So this is the close-up photos. So this is the highly accurate ground truth measurement that we have. This is the manual label. So this is a human that manually labeled all these holes here. And this is the proposed approach. So this is the automatic one where we detect the frame, where we automatically detect the holes. And as you can see, they nicely match. And this is the WHO standard, which grossly underestimates the size of the holes. There is still a discrepancy here that we are investigating. Why is on the coarse images, why do we normally underestimate the hole size? But the fact that this year, that those two nicely correspond, in principle, since our AI algorithm has been trained on these segmentations, we cannot expect him to be a lot better. But we are still trying to find out what this discrepancy is caused from. Here you can see the latest data that we have, and this is now sorted according to the size of the close-up images. So these are different bed nets, and as you can see, this bright or this mint bar here, this shows the size of the bed of the holes with the WHO standard. And as you can see, this is way overestimating the real hole size. So the dark green one is from the most accurate from the close-up photos. Then we have the manual labels, and the third one is our automatic AI-based one. As you can see, the manual one and our AI, they always correspond nicely, but they always underestimate a little bit the size, whereas for small holes, the WHO standard overestimates. If you look at this for bigger holes, then it looks different. So this is from the close-up images. So this is the manually labeled ones, and our AI, they still correspond quite nicely. But we can see that the WHO standard generally underestimates, but this also varies a lot. So if you look here, it varies a lot. I think the fact that our method underestimates slightly with respect to the high resolution images is probably not that much of a problem, because at least it is consistent, the results we get. But we still try to aim to find where these differences are coming from. Whereas with the WHO standard, you can see this varies a lot, and this inconsistency makes it, of course, difficult. So I think we have found a way to assess these bed nets with an automatic way. But as Sarah already mentioned, we would also like to try to make predictions. And for this, I also had a team or a PhD student working on a very interesting method that we might actually use here. And we are going to submit this anytime soon, I think this week. And this is something that we call TAB INR. Because as you have seen from, I think from Sarah's or from Emmanuel's presentation, I don't remember exactly who said it, but that we want to acquire a lot of data about the different households. So this is all tabular data. So this is big Excel sheet, how many people live there, how many bed nets. I don't know exactly what they're all acquiring. And this is tabular data. And of course, part of this tabular data is then also our bed nets hole sizes that we detected for 12 months, 24 months after they have been distributed. And with our TAB ANR, we can actually train now an implicit neural representation, which is quite a fancy new way of using neural networks or AI methods. And we can use this tabular INR to basically make then these predictions. How does the bed net then look like in the third year after deployment? And this method can be readily used. It is, once we have the data, we can actually use it to make these predictions quite easily. Okay, with this, I would like to conclude. I think Emmanuel already showed a nice overview of all the people that are involved in this project, and I'm open for any questions.
Thank you. Thank you for taking us
Don't feel too much alone.
in how AI and visual images can transform the field of monitoring. So thanks for taking us through this. So then, yeah, I invite all the presenters. Do you want to take a chair? Do you want to stand? Are you okay standing?
Is it very bright?
That's better.
There we go.
And I will, yeah, open the floor for Q&A sessions. If
Didn't make it black, the screen. Then it doesn't not shine into our,
Yes, I can.
or mute the projector.
just mute there.
Yeah, okay.
There.
Nice.
Yeah.
Yeah, thanks for this lovely presentation. Great work, very impressive. I was wondering whether or how you take into account the position of the holes. I guess the size is one thing that matters, but the position,
Yes.
on the one hand for the user, but on the other hand also for the mosquito, depending on where the holes are, they might enter the net more easily.
Yes. Yeah, it would be a good idea. We also talked about this because I think tiny holes at the top, they are more dangerous than the big holes that you tuck under the bed net anyways. But so far we have not thought about how to combine this into one index. So you have the ideas?
So we do have a data set on where holes matter the most. It's still on my long list of publications. So we can combine with this imagery and actually say, okay, so this net type is getting damage in the places that are most dangerous, and it actually is lower down. Some of the Phil McCall's work where we're showing that the mosquitoes are up at the top is a lot to do with airflow. And when you actually look at larger data sets, we published a meta-analysis on this year. Larger data sets, it doesn't matter as much. The really dangerous holes are quite low down because mosquitoes are coming quite low. And then they're just above the tucked area where people are lying because they can get in and get out safely. Because if they can get in and stay in, then that's fine because they're dead. So yes, I think it's simple to say we could then use these images to say that's a danger zone. That net type is probably less likely to prevent malaria than maybe one that has holes in a different location.
Maybe just more technical question. So I guess there's two types of torsions. So one is the angle of the camera facing the net surface, but then the lens itself has some kind of
Distortions, yes.
Could that be somehow related to the size differences?
Yeah, I don't think so, since we have the same lens distortions when we look for the corners of the net, and I would not expect this to be an issue. What still might be an issue, well, is that depending on the stretching, the holes that you then have when you tuck it underneath the bed might be slightly different than the one when we put it over the frame. So this is still something that we cannot correct in any way because we don't know how people use the bed nets. Yes, but I think lens distortion, I don't expect this to be still an issue.
I had a follow-up question on this concerning the uncertainty that you might have in your data. I was wondering if you also looked at when you don't correct for any of the distortion that you might have, the wind, like the order of magnitude that you have in terms of like the sizes that you measure versus the uncertainty that you would have if you were doing this multiple time. Have you looked at how comparable it is? Is like, do we really like measure?
Do we gain accuracy when we make these corrections?
Yeah.
Yes.
But like in terms of like, how does this like gain in accuracy compare to the uncertainty or certainty that you have in your data? Like, because I'm just thinking if we project it in terms of like trying to make it like usable in a regular manner, like reduce how like the cumbersome it is to actually measure this, and then just trying to understand the magnitude of like how much you gain and versus how much effort it requires to do all of this extra effort.
I think, I mean, it's a computer that is doing So it's rather easy, but currently I think that the wind correction we don't do. So at least in the table that I have shown, the last, there's no wind correction implemented there. But I think this is fully automatic. So we don't really care if one of the error sources corrected takes 30 seconds or not.
Okay.
It's a computer that is doing it.
Okay,
So.
yes,
Thank you. My question going on to the implementation team, like, were there any nets that were lost, or if yes, which brand, and what were the practical reasons?
So far, we have just distributed, we have not done the follow-up. So we're planning to go back in this December to see what has happened.
For trials in general, in the first year, you get a lot of loss where people are distributing their nets, where they might give them to their kids going to boarding school. And then years following that is because the net's getting damaged. That's the major reason for the net loss. And then they're often discarded or repurposed.
Is there expected number that was counted for?
Sample size less.
and if you can follow up, when do you start saying that this is discarded? Like, are you saying per person, a net per person, or per household? Because maybe the person who received the net is not using it, but someone else in the household is using it. So that still counts if you can still track. Where do you say that is being discarded to someone else?
So when you go back, for every net that you have distributed, we need to understand what is happening to this net. For those which are not there, we need to know the reason. Whether have been given to someone else, they are damaged, or they have given to students, to the farm, all these reasons. We need to record them, and later in their calculation for lifespan, survivorship, we need to include this so that you can understand it clearly what the main driving force for this. So we know all these parameters along the way.
So we have two classifications. One is lost to follow-up, so the net is still in circulation, so it's been given away. And then the other is definitely this net has been discarded, and so that would be attrition.
Okay,
So, because sometimes you'll find in year two, nets will come back again. So you wait until the very end of the trial, and then you'll actually only look at the ones which are definitely attractive.
yes. Yes,
Very nice question about like this prediction model. So it would be possible that in the future that somebody in the household has an net and you say, oh, here is more. I just go with my phone and just check it. And I just need to say, I have a phone with this model, blah, blah, blah. And like the camera could be already calibrated. So like the model can interpret which potential distortions have and predict it for the user to give them information. Because at the end of the day, not all of them will do the actual right to put the thing, make labeling and something like.
Yeah, our prediction model will be trained on 12 month, 24-month follow-up data. So we will then not be able to, from one single hole, predict on when the bed net will need replacement. We basically need then the status on this frame. I think this is more than on a general purpose, such that Emmanuel can learn which regions do we have to redistribute the nets. It's not.
It's no more like in the future, it's not intended for in the UI.
No, this is my understanding.
it's policy.
And,
Yes.
and I don't think it's a naive question because we actually discussed it earlier today. But there could be a thing called desirability bias. So it's like the good people, if you like, in inverted commas, the ones that are taking care of their nets are more likely to take the photographs. And so you get completely distorted view of how the net crop really is. The people who don't care are not going to bother taking a photo.
Yeah.
So we have to get some sort of sample, but we do need to find innovative ways to make it as easy as possible. So, you know, all ideas need to be thrown at us.
Yes,
To what extent does camera quality and settings affect the AI detection of phones and phone measurements? And does the model take this into account? Do you have like a specific set of settings for the same camera while taking this, while Emmanuel is taking the same
Yes.
picture?
No, currently we don't require the cameras to use a very specific setting, but we basically leave to the automatic white balance, automatic brightness control, and these images have been good enough for us. So we did not notice any big issues on that for certain images. It did not work. In principle, the more images we get, the better it is, but it's not that the settings are fixed.
Amanda?
If you could ask the net manufacturer to make propensity for image analysis, what would you ask them for that?
Great question.
Print the chessboard on the net.
A tartan net.
I mean, yeah, a chessboard on the net would probably be interesting, because then you can see local stretching. But I think the images are of such high resolution. When you zoom in, you can also see the individual how do we call this?
Weft and
Yes,
weave. Right?
weave pattern of the net. So in principle, one could go even deeper and try to have an estimation how locally stretched the bed net is, even with what we have right now.
Ooh, that I didn't know you could do that. That's
Yeah, we
very
didn't want to
handy.
tell you. It's just an idea we had, and we looked at it in the very beginning, and the images are of good resolution.
But we're
It
always
should work.
we're looking for better knitting patterns at the moment, working with manufacturers, and if you can get that high resolution, it could be useful.
Yeah, you want to have. Yeah, what's the application?
So they're looking at different ways to do the weaving.
Yes.
And if you can tell that, you know, different weaving patterns have less stretch this way and that would be very helpful.
Uh-huh.
Because the Gates Foundation threw about 10 million on
Yes.
figuring that out.
Okay,
Yeah.
give it to me and
There
we'll
you
figure
go.
it out. Half of it is enough.
I'll let them know.
Yeah, okay.
Could you say a little bit more about the health outcomes of the trial? You're comparing three groups, and so the obvious analysis is to look at the performance of the nets, but how are you going to use the outcomes to try to figure out these predictive indices and possibly then in the next step, improve procurement?
Can I throw that at the trial statistician?
So we don't have any data on malaria.
So you don't have any malaria outcomes.
And we ummed and ahed about whether or not putting it in, but because the cohort is the net and there's so many confounders, we thought it would not be very useful.
Yeah, that makes sense.
And we don't have enough money to do a cluster randomized trial, which would be amazing, but no, not right now in this climate.
I guess the quality of the net also depends on how often it's used. So in an extreme case, if you hardly use your net, it will last very long. How do you account for that in your study?
Yeah, this is very much a bias in all ITN studies. There are movement sensors you can put on nets. We decided against that. You can put markers on like dyes, but that's another thing you could do with image analysis, actually fading markers. So those are things that we could think about for longer term studies in the future. But at the moment, we're relying on people's general recall, and then we just take that as an average for, you know, for a community, because people tend to, and we try and ask the question in 3 different ways, so we don't get this desirability bias again. Because people always want to come across as I'm super clean and look how well I take care of everything.
Yes.
I think Emmanuel talked a little bit about including the community and the preferences. And you, Sarah, you indicated that actually the choice or the procurement is not the households, but the donors. So did you include the donors also in this group of people that you engage with around the project? Or how do you facilitate it having impact there in the decision makers?
So the key decision makers basically want the greatest malaria impact for the cheapest price. They don't really care about anything other than that because they want to save lives. So we have engaged with them. In fact, you were there when we had the Durandal meeting where this was discussed. And basically there's a level of frustration, I think, because some people are saying, oh, WHO should enforce it. And then WHO is saying, no, it's not our mandate. It should be the procurers. And then the National Malaria Control Programs are saying, but actually we want this net, and everyone's not listening to them. So Emmanuel is doing an amazing job engaging with the Tanzanian National Malaria Control Program and what they want. And now we're hoping to create this circle where that goes to procurers, because we actually demonstrate value for money. And we demonstrate the National Malaria Control Programs have a preference. And the nets have been designed based on the preferences within the country. In terms of the reason people don't use nets is because it's too hot, so you make it nice and airy, or it's too rough, so you make it smooth. And then the damage resistance was a part that we put in as part of the project. And then we added in a super insecticide just to get the maximum malaria impact, although sadly we can't measure it, which makes me a little upset. But you know, we're going to use mathematical models to figure out what the impact is likely to be. And hopefully that will persuade the procurers a little as well.
One question? I had a question about you talking about the insecticide. I was surprised and happily surprised to see like how for the ultra durable nets, even your entomological efficacy is like stronger than IG2. That's even not talking about the physical durability of the nets. Why are we not switching just from the insecticide perspective and just like for 1 second forgetting about the physical durability? And then would you recommend then that we move, and I can't remember exactly the name of the insecticide, but like from the current insecticide that we have for IG2 to the one that is on the durable nets?
I don't think we should switch completely, because there's a lot of, again, modeling data from resistance studies showing that we should be rotating our pyrethroids as well as our chlorphenaphyr. So having a selection is a good thing. I think giving the bifenthrin nets a good chance is definitely necessary. And at the moment, there's a lot of nastiness going on in the bed net market to try and, you know, get the few dollars that are available. So it's very difficult to lobby for this particular insecticide. So we're just using data and hopefully that will be enough. Yeah.
If I just want to add, in the community, I think most of the people decide to discard the net simply because of the physical damage and not the insects.
But one thing we've added in is it's highly effective against bed bugs as well. So that's going to make it, hopefully, users are going to want to use it a bit more. Because back in the day, when the original bednet trials were being done, people measured things like impact on head lice, impact on scabies, impact on bed bugs. And we've added back those questions to see if there's any difference between the three products and how that might affect user acceptability.
Yeah. And then going back to the evidence that you need to provide for the donors, the way it works is also, if it's the donors who's going to decide more or less like what nets they're going to buy, is it a Tanzania issue? Or is it becoming like a regional or global like questions where they want to probably buy bulk and then probably distribute to more countries? So is there a plan to also go like more like evidence beyond just Tanzania and just saying that this is, I mean, it's a good proof of concept, it works well, but like to provide more evidence for more, do you have a plan?
We do. It's very early on because we need to get it working in Tanzania first. We want to do the proof of concept there, but I've had discussions with multiple different countries. Everyone's interested in this. Everyone wants to know how they can actually figure out when do we need to replenish. I mean, just knowing that is enough, even if it's not going to change the bednet procurement market. But at the moment, as I'm sure you're aware, we have volume guarantees. There's limits to the amount of funding. And so they're bringing the price down of these more expensive nets by getting large volumes from just 2 manufacturers who are extremely powerful. But now we have more nets coming to market. We hopefully the price will come down and selection will be able to start. But the volume guarantees until the end of 2026 with Global Fund. Right now, nobody knows what's going to happen beyond 2026. We don't even know how many dollars are going to be available. So let's see. But if you can demonstrate value for money, I think now is the time to be demonstrating it.
Doing more with less.
Doing more with less. I mean, this is bringing me right back to my roots when I was a student, listening to what was going on and how much had to be done with how little. And then we went through the sort of wealthy years where everyone was throwing money at everything, and now we're right back to where we were. And every single cent counts. Yeah. You had a question, Jane.
So, yes, first of all, congratulations for the nice presentation. I really enjoyed about the from Sarah's, Ima, and also Bob. Just out of curiosity, because I believe now the net has already been distributed, and then after 1 year you go to follow up. So with an assumption that the net will be maybe torn, will it be accounted torn and then serviceable? Maybe he liked the net and wanted to use it and maybe service that, or will it be accounted for the image analysis? And I was wondering, maybe the difference between the manual and image analysis maybe did not account for those time. I mean, for those serviceable calls that were already in the net. That was what I was trying to think about it.
I was talking about the repair.
Yes, yes.
Actually, both image analysis and the manual work that we are doing really doesn't, as long as the net is repaired, we assume that is still intact net. But we note down this net is already repaired, because it can happen this time you got the net is damaged or too tall. Maybe over the sudden this user changed the behavior and decided to repair it. Next time you come, it is actually a good net. So the moment we assess the net the way it is, if it has fault, we'll record that way. If it is repaired, again, we'll record as if it has no fault at all. But it's noted that this has been repaired. Because as Sarah mentioned, we're also assessing native care attitude, which is a very important aspect. Yeah.
I was just going to say that exact point.
No more question? Yeah.
Wouldn't it be interesting for the model maybe to say that it has been repaired so that the prediction later can take that into account in the data that we receive?
Yes, I think that is one of the variables that will be included in the full data set.
Yeah, like in the first one.
Yes.
So what information is provided to the users of the nets when it comes to, like, let's say, how to use it, what could be avoided? Is there anything provided, and if so, through which channels? So in these community engagement talks, is that also a topic?
One thing during the implementation distribution, we just inform them about the net, and we allow them to use the net in the common use, because we don't want to have so much restriction in trial setting, and then once this net is deployed through government channel, these people behave differently. So we just not have so much restriction in terms of usage and anything, apart from just use the net the way they want and let them be free. For example, some of the households, they can receive net today, and just after 1 week, they decide not to use it. So we want them to be free. Even if they stop, the only thing that we want from them, if they stop using the net, for example, when you come back, we want to know what the reason they stopped using the net. And that information is very important for us to inform. Maybe we have to change them. And also this aspect of adverse effect. So some people can stop because of adverse effect to the net, and then they stop using it. So for us, collect all this information. And they can help us even advise manufacturers, investing, I mean, all the parameters that you observe.
And this is super helpful because, I mean, I think it would be good if the label said, try and wash as little as possible, for instance. Because people wash their nets way too often. And every time you wash a net, you're removing insecticide. And it's also environmentally an issue. So having the insecticide stay on the net is a good thing. Apart from that, though, I don't think there's anything that I would want people to do differently.
But the narrative you mentioned that even a net with many holes, it still makes sense to use it. So is that narrative pushed somehow?
No, just be free, as you said. And I mean, there are many things you can do to make your net last longer. You can fold it away during the day. You can make sure that there's no cooking going on in the room where that would create soot. There are many, many things, and we're collecting all of that information. And that could be used in behavior change communication. In fact, it has in many countries, but that's not the aim of this trial. It's to see, you know, can we find a way to make bed net monitoring cost efficient? And if so, can we then maybe persuade procurers to buy it based on quality?
So just a small follow-up on this. Would you suggest then, or same in community engagement campaigns, to also tell people to, instead of discarding the net, it's better to hang them on the wall or somewhere in the bedroom rather than completely getting rid of it? Because even if there's no physical barrier, there might be still insecticide that deter or kill the mosquitoes. Would that be a possibility just to also encourage this message?
I would love to see them repurposed for window screening, eave screening. That's ideal. And with the bifenthrin that we're using, it's very photostable. It doesn't evaporate very easily because it's a large molecule. So you could use it for screening quite easily.
So there's a big gap in communication to explain that even if it doesn't work as a physical barrier, it's still very helping them to get rid of like the mosquitoes, like by deterring them.
Yeah.
So doesn't bifenthrin also have quite a repellent effect?
No, that's the beauty of it. It's the opposite. It's not irritant at all. So the mosquitoes hang out on it and get a much higher dose. Yeah. And we knew this in 2003, and it wasn't selected, even though it's an ideal molecule, because it's a few cents more expensive than alpha-cyclomethanol or dotamethrin.
One more question? I'm running out of my questions, but it was really, really interesting. So I'd like to thank Sarah, Philip, and Emmanuel, please. This has been a very insightful seminar, at least for me. I hope for everyone as well, connecting policy, field setting, innovation all together and trying to get better ways to use the tools that we already have that made it even stronger and like more sustainable. So I hope this has generated some ideas to some people, some collaboration. And so please stay for the apéro, continue these discussions, and thank you again for everyone for your questions and for presenting today. Thank you.
Thank you.